Good morning, and thank you for joining today's webinar from Spec Innovations titled, Is There a Return on Investment from Model-Based Systems Engineering? My name is Joanna Moore, and I will be your moderator. Before we get started, let's go over some quick housekeeping. During the presentation, feel free to send us your questions, and we will get them answered in the question and answer part of the webinar. You can also interact with us on LinkedIn through the InnoSlate user group or through Twitter using the handle @InnoSlate. The webinar is being recorded and we will make it available to you after the live presentation. So be sure to keep an eye out for it in your inbox. Now, I would like to introduce to you our presenter, Dr. Stephen Dam. He'll be sharing with you an analysis on the value of model-based systems engineering. Dr. Dam is the president and founder of Spec Innovations, as well as one of our DODAF training instructors. He has been involved with research, experiments, operations analysis, software development, systems engineering, and training for more than 40 years. Dr. Dam is a member of the LML Steering Committee. He has also received an Expert Systems Engineering Professional certification from INCOSE, and currently he is applying system engineering techniques to various DoD, DOE, and commercial projects. Feel free to send Dr. Dam any questions through the LinkedIn user group or send him an email. And now I'll hand over the controls to Dr. Dam, and we will get started.
Okay, just a little bit about us. We've been doing this work in systems engineering for a long time. The company's been in business since '93. I personally have been doing systems engineering work probably since the early '80s to mid '80s, working at places like TRW, Rockwell, SAIC. So a lot of experience in this area, understanding the problems. Particularly, a lot of what I did was proposal work. So I had to do, as a project engineer at Rockwell, I was required to do cost estimating for every proposal we were doing. And so we had to create at least a tier 3, usually had to go down to tier 4 and roll up to tier 3 work breakdown structure to do this. And so I've had a lot of time to think about these kinds of problems. And one of our customers recently came to us and said, well, how do we know we're getting a return on investment from this model-based systems engineering stuff? And in fact, INCOSE has already started a group. It's called the Value Proposition Initiative. It's just looking at this very carefully and trying to understand it across the board. I thought I'd take a crack at it from our perspective here at Spec Innovations, and using our InnoSlate tool, we get this all the time from many customers. So I said, well, I just sat down and said, well, how would I go about really looking at this problem and dealing with it? And so model-based systems engineering itself, as a term, came into being really sort of middle of the last decade. So I think the first time I heard it associated actually with another tool, Vitex Core, was where I heard it originally, and then applied a little bit more broadly, particularly when SysML came into being. A lot of people were making that equating those. So, but you know, if you look at the actual definition of systems engineering, it's something we've been doing for a long time. It's basically modeling is not new. It's more how do we use it to do a better job of systems engineering and make it faster, better, and cheaper. So one of the things is, first of all, you have to say, well, is there a return on investment on systems engineering? And I think there's a lot of evidence for that. These are just a couple examples. One was from a paper by Ivy Hooks, by some work done by Warner Gruhl at NASA. And this is a classic looking at all the different programs and how much they were spending roughly on systems engineering. It wasn't an exact thing, but systems engineering and probably program management together. So if you look at this curve, you can see that there's a kind of a sweet spot in there. I'll talk a little bit more about that in a second. Another one more recently that was done was by Joe Elm, who's, by the way, the president of the NDIA Systems Engineering Division now. So in fact, we have a conference next week where he'll be presiding over that. And anyway, so he works for the Carnegie Mellon Software Engineering Institute. And so he did an analysis along these lines. And you can kind of see where if you're doing more, if you look at the bar charts here, they require a bit of explanation. But basically, low SEC means low systems engineering capability. In other words, they didn't do enough systems engineering. And so you start to see the performance, you see the performance of that project has degraded. I mean, it's only 15% of those projects are high performance. Most of them, the vast majority, 52% are low. If you go to the higher end though, you see that gets flipped. You have 57% that are high if you're doing a lot of good systems engineering. And a lot fewer that perform poorly. So again, it means that they're not perfect, right? I mean, systems engineering is an art form a bit as well as a science, like any other engineering discipline. And so it requires a bit of both, and you end up with programs where, you know, people just aren't as well trained, or maybe they don't know how to use it as well, things like that. Even if there's a higher set of processes and things for it, if you don't know how to do the work, it doesn't necessarily work out very well. But so looking at that value, that return on investment, particularly if we use the Gruel chart basis, that roughly says we need to spend roughly between 7 and 12% of the program budget on program management and systems engineering. And there's a huge overlap between those two disciplines, which we recognized recently. PMI and INCOSE wrote a book jointly on the integration of the two, which is kind of interesting since we recognized that about 10 years ago. But it was great to see that it came along with that thought too. Anyway, so the key is that this basically says you have a return on investment of almost 10 times the original investment if you do this correctly. Because and I just use a simple example of if you spend $100,000 on it for a program, that's the overall cost of the program is $1 million. If you hadn't spent significantly less, it could easily have doubled the cost, and that would be tremendously disadvantageous to the program. Again, these are rough, and so but at least give you a feeling like systems engineering does have value in and of itself. Okay, so how does the modeling help systems engineering? What are we doing that's different than what we've always done in systems engineering? When I was at Rockwell, we didn't have personal computers. When I first got there, or at least they were just coming in. So most of the things were still done in paper form, and we had libraries and all kinds of librarians to track everything, and it was quite a job to keep track of all this information. So modeling was part of that, though. We always did drawings, we always did flow charts and things like that. So that's not special. And so one of the things we've seen, though, unfortunately, is that MBSE has been kind of being pushed now by the community, and a lot of people have equated MBSE to SysML. Well, and of course, then they do the next equation, which SysML, the best SysML tool out there is Magic Draw by far. It's very obvious to see that as far as it goes, that's certainly is people's favorite tool, it seems like. But the question is, does SysML and Magic Draw do all the things we need to do in systems engineering? And I will contend no. I think we can show that here in a little bit. So what we need is a good set of system requirements to look at that people can be used by all the stakeholders. That's the problem we see with SysML, is that it's sort of like hieroglyphics versus an English language text. If you can read hieroglyphics, it's great, but if you can't, it doesn't have any meaning to you. And that's kind of what this is. It's kind of a code set of drawings. So the thing is that what I said was, let's start with looking at the systems engineering tasks themselves. What do we have to do particularly that overlap between the systems engineering and program management. If you look at, back to Joe Elm's paper, he actually had a set of tasks that needed to be performed and that they looked at and evaluated as part of this. So this is that set of tasks. And so I went and kind of grouped them. I thought that was a bit of overlap in a number of these, particularly in terms of the capabilities of the tools and things to support it. So, so first of all, I wanted to compare SysML, which is 9 diagrams, diagram types, I should say. You have to make many versions of them, by the way. It's not just 9 diagrams you're drawing; it's many drawings. And then so again, that's mostly been derived from software engineering practice, not systems engineering. In fact, only 2 additional diagrams were added from UML, which is SysML is a profile on UML or an extension of UML. And in that, they only added the parametric diagram for equations, which as a nuclear physicist, I absolutely hate. And then secondly, the requirements diagram, which is kind of useful and it has some utility to it, but again, it's not the way most people look at requirements and want to deal with requirements. So it's just, again, it's just a different approach. And the problem we've run into and we see is that it's very confusing to people. So lifecycle modeling language was developed as a way to deal with it from an ontological basis. So, and they recognize this deficiency in SysML, and they're off working on that, and supposedly in 3 years they're going to have a new ontology for SysML. But LML was designed to subsume SysML and provide that ontology for it today, and it does. I think we've demonstrated that capability with INCOSE to show that. And to learn LML, you can see there's a nice thin little paperback book there next to the SysML books, which people have felt that you needed both those books to understand SysML in any depth. And so you say, well, gosh, that sounds like LML is very simplistic. No, I would call LML elegant. It actually has all the information, it captures the information you need, and you have multiple ways you can display the information visually. And so the SysML diagrams are part of that group. If you want to see LML information displayed as SysML diagrams, it's very easy to do. And so, and I kind of, of course, got ahead of myself as I usually do. So, in fact, let's take a look at that specific instance. So here's an example of the action diagram from LML. And you can see it's fairly readable. It's fairly easy to understand. That's a loop. So there's a loop entrance and exit criteria. That's actually a type of action, so which means it's allocatable. Same thing with the OR. And there's another point that we have. It's a sync point. And that's it. For the logic elements, that's all we found we needed. Okay, so that, again, that's an elegance of the simplicity of making this language a little simpler. So this is the one diagram that's kind of unique in LML. If you look at the equivalent in SysML, well, I've got these diamonds and I've got forks and I've got stuff in there. And again, if you know what they mean, it's fine. It's easy to understand. And I certainly get it. It's not a problem for me to understand it. But to explain it to a customer who doesn't understand that language, they get very confused. And actually seeing multiple diamonds gets people like, what? Wait a minute, that's a loop and the other is an OR? Really? Okay, I guess if you say so. You know, it's kind of thing you get. And plus, those are now allocatable. I can't say who or what performs that decision point. I'd have to add that as a separate thing someplace in that diagram. And again, they don't have that concept as much in SysML, I don't believe. So anyway, so this is one of the things we found, that people pick up the action diagrams and the LML ontology much quicker than they do the SysML. And so can Magic Draw overcome these limitations? Well, the answer is really not well. And so if you go back to those set of tasks, about the only one that Magic Draw itself covers is systems architecture development. The other ones really, I mean, it has some capability to do like requirements and things like that within the tool, but it's otherwise very, very limited in terms of its capabilities. So people supplement it with lots and lots of other tools. In fact, we estimate it takes at least 7 tools to do that set of jobs. And I'm going to be walking through those in a minute here. And so InnoSlate, though, is a full lifecycle tool. We built it that way on purpose because what happened was we were using other tools for years and years, and I sat on a committee in INCOSE for I don't know how many years, which is a tool interoperability committee. It became very obvious to me after a while that the vendors don't want them to interoperate, not really. And even some vendors have bought multiple tools and they kind of kludged them together, but they don't really interoperate in the same sense you think of. They're not using the same database. And that's actually a big deal because keeping configuration management in your database is very critical for model-based systems engineering. If I have to do all that manually, that's not much different than using Microsoft Office in reality. But we have that whole life cycle covered. We're also adding in all kinds of techniques to do verification, like using natural language parsing to do requirements checking and things like that. We have the Monte Carlo simulator, a discrete event simulators that built into the tool, automatic. It's just part of the tool, not special, not a plug-in, nothing extra, because you need all this. This isn't stuff that's just nice to have. This is all stuff we need. We also have risk analysis capabilities, things like that. So again, it's a very complete package. And of course, the question is, can LML reduce our investment costs? And so we're going to look at that as well. And of course, the fact that we use this modern technology to automate some of these difficult tasks really gives us the ability to do something more for the users. And so that gives them much more value. And so you look at that, clearly what we've seen is it does provide a higher return on investment than using just Magic Draw and those related tools, doors, and some of the other ones we used in our estimation here, what we're going to see. And they are expensive. That's another bottom line you'll see here in a minute too. So let me quantify this, because this is all, kind of, if you think about this kind of makes some sense. And in fact, intuitively, I kind of felt this way for years. That was the problem I was having is, are those other tools that much better than just doing Visio and Excel and Word? So what I wanted to do is quantify that, because again, one of my customers was asking for this, so I said, I got to do this quickly, get something good. So what I did was come up with, say, there's sort of 3 techniques: ad hoc, which is mostly using the Microsoft Office tool set; the SysML approach, which heavily uses doors and Magic Draw and a bunch of other tools, I think Risk Radar, and a bunch of other things we looked at, that Microsoft Project for the project planning part of it, because that's all. If you saw, there was a lot of scheduling kinds of things in those systems engineering tasks. And of course, just LML and InnoSlate as the way to do it. So taking those 3 different approaches is what I tried to estimate. And what I did was take those tasks and grouped them and broke them down to another level. And so so each area, I broke it down into 3, 4, in some cases 5 different subtasks. And of course, you could do more, but I think the idea was to get the basic set of things you do as a systems engineer. And so obviously we want to do further analysis on this, but I think this is a good starting point. And so we actually looked at each of those for each of the different approaches: the ad hoc, the SysML, and the LML approach. So basically, one of the things that we typically do in something like this is we actually create a basis of estimate. And that's, again, what I've done for proposals for decades. So I'm pretty qualified to do that kind of estimating. And so looking at the work breakdowns chart, because basically I can take that list of tasks and use that as my basis for it. Normally what I do is we'll estimate the labor cost and things like that. But the problem is there's so many assumptions in doing that it kind of doesn't really get to what we're trying to get to. So instead of taking that approach, what I did was something where we could kind of create an ease of use score. In other words, kind of a relative score between how easy is it to learn and use and apply the tools to a project. And so that made it more of a relative scoring. And we did that by estimating the amount of time it takes roughly to do each of those tasks with each of the different approaches. And so I ended up with a pretty complex worksheet here in InnoSlate. This is actually from our database view. And so we looked at the different tasks and really tried to define the tasks very specifically as what we're doing and what's taking the time to do each one of these things, and for the different tools. And I wanted to make sure, I mean, I did a first cut at it, but then I had experts who had just come off using Doors and Magic Draw particularly, look this over, and they did bump up my numbers a little bit, but in general, I think I was pretty close the first time to that estimate. So there's a lot of detail here, and I'm going to show you the actual project where I did this in as well, so you can get an idea of the depth of the analysis. So bottom line though, when I compare them, it's pretty clear that the ad hoc and the SysML, the SysML shows slightly higher performance, easy use, and that's okay. Maybe, again, maybe that's worth it to you to make the difference between the expense of those tools and time and the training versus just using Microsoft Office, which people come out of school knowing pretty well these days. Our digital natives coming into the workforce, it's particularly easy for them. But LML clearly in InnoSlate is showing a much higher return, much more easy to use, and that's what we've seen too. I mean, we actually, it's kind of funny because we provide support to all our customers, and that includes free customers. I don't know if anybody knows this, but I'm probably going to get yelled at by support staff when they get inundated with calls, but we haven't been inundated with calls. And the reason for that is we have so many resources online that people go to, the webinars, the YouTube videos and things like that we have. It's very easy for people to pick it up and learn. And we have probably 1,000 students every semester using the tool for the first time. And we barely hear any problems that they have with it in general. So I think that's a pretty good indicator of ease of use as well. That's anecdotal. So that's why I was trying to quantify it. Also, there's also startup cost to these things. Okay, so Microsoft Office is, I mean, roughly around $500. I mean, I'm including the whole suite, and things like that. And of course, you have upgrade costs on an annual basis. And so the training costs are basically none. I just said none because, again, most people come into the workforce knowing it these days, or at least knowing it well enough that they can use it effectively in what they're doing. And then the SysML tool set, the $30,000 estimate was actually from our Navy customer. The Navy Systems Engineering Resource Center estimated that we replace about $30,000 worth of tools. And our list price for the cloud is $2,000 per year. Okay, so again, yeah, there's probably a crossover point at some point, but in general, there's a lot of value there that you're getting quicker. The other thing people are saying is it takes quite a bit of training to learn SysML. And you saw those books; those are substantial books to go through, and people do whole courses on them in a semester. And it's quite a challenge to get through all of it. So what we found is that it really just gets started. At least it's one day. The bigger problem we find people having is not knowing how to do functional analysis, and that's the kind of basic skill that you hope your systems engineers have coming in, but a lot of them don't. And so that's where most people struggle with these tools, by the way. So that's part of it. And so when you do training, sometimes you need a little longer just to learn that as well. We provide a special kind of training. We actually do what we call workshops, where we're actually working with the customers on their problems and helping them learn the tool, but using the problem that they're working on. And so that's a huge value add to people as well. So they're paying for training, but they're actually paying for consulting and getting started faster as well. So it's kind of a win-win with that one as well. So a lot of value there. So the bottom line is, when we look at that return on investment, SysML versus LML approach, it's clear that SysML is just more expensive. And in fact, it kind of has a negative ROI compared to the Microsoft tool set, because it's so hard to get used to and work with. And then, of course, the other problem is on the other end of things when you're trying to talk to other stakeholders, particularly ones that aren't working with object-oriented software development, because most of your other stakeholders are not. They have no idea what you're talking about, and it just flies over their heads. And I've heard many horror stories over the years for people trying to do it and work with it, and it just doesn't seem to work well. And so clearly, if we're going to have value for model-based systems engineering, we need to use a good methodology for it, and something that really is designed to work around it. And LML and InnoSlate were designed to work around this. And so that's why we think we think there's a lot more value added using our approach. So let me show you a little bit quickly about the guts of this and getting into the actual analysis. So let me get this going and make sure it's current. Yeah, so we do timeout on the cloud on purpose. And so this is my project for it. And best thing to do is go to the diagrams first here. And so here's that hierarchy chart of the tasks. So here's how we did it, and each one of them we talk and try to define. See the sidebar here, you see the description field is showing the definition. So we're defining what you're doing in each one of them as you need to go through the process. So let's see, and then another diagram was this now. So now what we did was we took that and took each one of those and created a version of it so that each one of these would have for the different ad hoc, the SysML and the LML approaches. So I could assess each one of them specifically. And again, detailed descriptions on what we're saying we mean by each one of these. So this would be part of, if you're doing a basis of estimate, you'd normally have a description of here's what we're going to do in detail enough to say, okay, what is it? And then all we did was assign a score from 0 to 5. Okay, so if they didn't have the capability, it was a 0. If they did it well and it was fast and easy to use, we gave it a 5. Again, relative scoring between the different levels is how we did that. And I even started to build an action diagram model of this, but then suddenly stopped and said, well, gosh, that gets problematic. And it's, again, I'm back to that. Go ahead and put the cost values and things like that. So I actually did start that, but it just didn't seem to be a good path to go down. Also, another lesson learned, by the way, let me just mention this in here, was when we did the actual evaluations. I'm sorry, I got the wrong one. Go back to here. Yeah, this one's what I wanted. Okay. So when I created this characteristic, and this is just a characteristic class element, I added the attribute easy to score, easy to use score as a pick list. But that doesn't let me roll up the value. So I actually had to put in another attribute with the value this way. So again, as a scoring tool to help people easily pick the right numbers and not just put in point values or something else, whether they wanted ad hoc wise. I didn't do it that way, but probably I should have in the first place. It would have made it easier to roll everything up. I had to go to an Excel spreadsheet first, but then I went in and add this other one so we can do a roll up ourselves. And so now to go to database view, and I've got some saved queries on this thing. So I have the scoring comparison matrix where I was looking at the different tasks. So here's my systems engineering tasks, and then I was looking at the characteristics of each one of those, and roughly how long in time I thought each of those took. And so this is again something I did initially and had other people look over and make sure I wasn't just completely drinking my own bathwater. But so you see there's a fair amount of analysis that's gone into this. And then from that, I would select the score and create a score that's relative to it. So again, you know, scored pretty high some of these early things, but as we go down and look at some of the other tasks, the scores change pretty significantly. And you see some significant differences between things. And so that's kind of a quick overview. And then here was the matrix for the actual EOU. Easy to use. So this is another way to look at that same thing. If I want to see if for a specific one, I can go through and look at one. So this is just another way to look at the same data for that purpose. What's nice also is, let's see, in the, yeah. So if I look at another matrix form, again, I wanted to roll up the values. The way I do that is we have a tool. If you click into the highest level item here, which is this ad hoc ease of use total, and I wanted to roll those up, all I do is select roll up here and then select the value I want to roll up, and then it gives me what that value is. So if that value was something different, I could actually change that there. So if I had made an estimate that this was, I put in here 50. Okay, so now let me do the roll up, and it's going to give me 54, which is the correct number. And so I'm just going to apply that value to it, and then it'll make the change. So anyway, so this is something we can work with, and you know, it was an easy way to show it. Another thing I did was we do have a new charts view. So I was able to create an XY plot with the information showing those same values, the scores. And this is kind of not as quite as pretty as the bar chart. So I went back and did a bar chart in Excel to do the final thing. But we hope to be adding bar charts here soon too. That's just on the list of things to do. So anyway, I think that's the main part I wanted to talk about today. And so I think that means it's time for questions and answers. And let's see what we've got for the questions.
Thanks, Dr. Dan. I'll help you out with the questions here.
Okay.
Oh. Yes, looks like we do have a few questions. Your statement that LML saves labor over SysML and ad hoc methods assumes on Innoslate implementation. Aren't you really comparing LML as implemented in Innoslate to SysML as implemented in MagicDraw?
Absolutely, because I have to do it some way to do that. And so there's no other way for me to really see a good, I couldn't think of a good way to just do it ad hoc. I mean, because after all, if I'm just drawing using the Microsoft Office tools, the SysML diagrams or the LML diagrams, there's not very much value added, and there's no database. So you got to have those elements to do really model-based systems engineering. So that's why that's critical.
Oh, looks like a continuation of the previous comment. So you should not say that LML has a higher ROI than SysML. Would the analysis come to the same conclusions if you compared implementations by other vendors?
So I think so. I think they would end up being about the same, because I think the fundamental problem with SysML is that it's hard to understand and use. I liken it to looking at hieroglyphics versus reading a text. I mean, again, if you're an archaeologist and you know how to read hieroglyphics, it may be the same to them, but to everybody else, it's just pictures on a wall, and I don't know what they mean. So that's the problem we're facing, and we have to be very careful. Okay, so somebody asked about this being a sales pitch for InnoSlate. Okay, I don't know how to decouple the two. If I'm going to look at return on investment for model-based systems engineering, which is tool-driven, I have to tie it to something. So that's why I think that's important. So it says, oh wait, it's getting better. And I didn't show any ROI. I thought I did. I thought the return on investment is like double. It's like 100% return on investment. That's what I was showing with the numbers. So the easy use translates into lower labor cost pretty directly. So I think that's, and I'd probably say even linearly. And so I think that's a way that, or maybe it's even nonlinear. So again, that would be something we can do more of. But again, this is my first shot at doing this, and I will say that I'm planning to work with the Value Proposition Initiative group and present this to them and say, how can I do this better? How can we make a better way to estimate what we're doing and do this right? So I want to be fair to the other tools and the other approaches, but in general, my experience with SysML, and I actually had the experience with UML on the future combat systems for the Army. We worked on the program management requirements, development, our company did the architecture and the systems engineering for that project. And the problem they were having was that the UML diagrams were very confusing to most of all the other stakeholders. And they actually brought us in at that time. We were using Core as the tool for that. And by the way, Core can come do the same analysis, and the other people can come do the same analysis that they like. But you know, that to me is, gave me a lot of insight into the problems people have in trying to understand UML. And then of course, SysML just added 2 diagrams, which, frankly, didn't make it that much better. And particularly, again, as a physicist, representing block diagramming my equations is like when they made me diagram an English sentence in high school. I hated it. So why not just have equations? It says, will this project be available, and where can I get the LML book? Okay. So the project we can make available to you. I think that's probably on a per person request. I don't think we're going to put it up yet anywhere, although I think we are trying to work our share space. And if we do get it up there, I'll make that available to everybody. And then the LML book is available on Amazon. It's called Essential LML. And the lead author is Dr. Warren Vanneman, who's a professor at Naval Postgraduate School. Can I review the comparison of the results? Sure. Let me go back here. Go back up. Yeah. So again, the comparison here shows the difference between it in terms of ease of use. Again, that was the metric I came up with. Is that the best metric? I don't know, but it's one that made sense to me for what we're trying to do. Because really, the cost in using in doing systems engineering is in the doing of it. It isn't the tools. The tools actually are relatively cheap. But the labor costs are huge it takes to do one of these jobs, and to coordinate the information and to do it. I mean, one of the things that's a big difference between LML, or I should say InnoSlate and MagicDraw, is we generate all the diagrams and all the views from the data in the database. They can use the data in the database, but they don't automatically generate them and follow the rules. And so that's why they were harder to use. And that's why they're closer to Microsoft Office and that kind of thing than what we're doing. we would be much closer to a core or a cradle or some of those other tools that do that what's called, Dr. Vanneman calls concordance. And that's what we're looking at there. I hope that's helpful.
Next question, does LML support variant management, PLE, and integration with PLM tools?
So we can integrate with just about any tool using APIs. We have Java and JavaScript APIs, particularly JavaScript APIs that are only available if you're using our enterprise version behind your own firewall. Our cloud instances, we can't allow that because that's a huge security hole, but you certainly can use it behind your own firewall. And so that's a way to do it. But also we do a huge percentage of what the PLM tools do. We don't do everything yet. I will say that we don't do absolutely everything they do yet, but we do a heck of a lot of it. And I think you'll find that you don't need them quite as much anymore. We do have a CAD viewer. We have the ability to take the CAD information and break it into our own physical assets to verify the CAD drawing, for example. So there's all kinds of other integrations we're working on right now. One of them is Simulink. And so we're actually very close to having that ready to go. And so there's a lot of things that we're looking at to do that kind of stuff.
Next question, why do you think LML has advantage? Is it the language, the training, the tool?
So I think the language itself has a huge advantage because first of all, it provides a very simple set of classes of information that you're going to track and be able to capture the information in the bins. And then all that information can be related to each other. So that now I have that fuller traceability. It's not just requirements traceability, it's traceability of all the information I'm tracking throughout the database. That's very important. So that's a key part of it. But also the training, because it's easier to use and easier to understand, the training's much simpler. And of course the tool brings in things like NLP, the simulators, the full discrete event and Monte Carlo simulation capabilities, things like that that are just, again, fairly unique in the industry in terms of the capabilities.
Next question, what about Capella Arcadia?
And I don't know that well enough to do this estimating, so if someone else wants to do that and take a look at it, I would recommend they do something similar and send us. I'd love to see it actually, because I'll pass it on to the this INCOSE group who's working on the value proposition initiative.
Next question, is LML an ontology?
Well, okay, so in fact, defining an ontology is the set. It's a taxonomy plus the relationships between the elements of the taxonomy. That's the way it's defined everywhere I've seen it, and we certainly provide that capability. So yes, I think it's a complete ontology. We also have put it into OWL, and so you can put it there, but we have actually something more than OWL usually has. They only usually put attributes on the classes of information. We put attributes on the relationships too. So we actually have a fuller language because what those are the equivalent of is nouns, verbs, adjectives, and adverbs. And I think you need all of those actually to have a full language.
Next question. What's the best way to create a value-added deliverable to present to stakeholders that are not familiar with LML? I wouldn't expect them to click on each entity and read.
Of course not. And so that's why we have documents view. And in fact, that's the thing we find that's most advantageous for people is that they see that they can see the information as documents. We are starting to think of documents as a model too, because since you can make each paragraph, each piece of the document is actually an object in the database, then it's traceable. And now you can trace to it, but I'm just viewing it in a different form. I'm just viewing it as a document. And we can generate those automatically in a living form from the diagrams. So we can do that complete round trip between the actual modeling and the documentation. So it gives you that. And of course, then we can put them out as reports. So when you want to make it shelfware, you put it out to Word, and then you make that available to everybody that way. So that's a very easy way to create your deliverables. And then of course, once you do that, we recommend you save that as an artifact in the database, because that'll help you keep track of those items, and you can also note when it was delivered, how it was delivered, and again, it keeps it together with everything else. And of course, the baselining in the tool to baseline the documents at the same time. So again, all that's there, a much more effective way to do your deliverables. And of course, one of the things they're trying to get to is something called model-based reviews, where you never actually go to the Microsoft Office products, you do everything within the tool. We've actually been doing those for 5 years now, and one of our colleagues, Dr. Jerry Sellers, actually did that for all the NASA milestone reviews. So again, this is where the industry's trying to go, and we think has huge value. We're already there, actually.
Looks like we had a clarification here. I meant Capella Arcadia solution for MBSE.
Yeah, I'm sorry. Again, I still just don't know enough about it. So yeah, I'd recommend do take a look at it yourself and see if there's some way you want to make that same kind of analysis.
Next question, Stephen, thank you for the great presentation. So is it fair to conclude that there is a significant ROI using MBSE regardless of the tool? Consequently, the cost of the tool is not a dependent variable in estimating ROI.
So I would say it's marginal, maybe with the using the SysML tools and that approach. I think particularly SysML itself is problematic, again, because I think it's hard for people to understand. Again, if you're an expert in it, it's great and you get it, but you have stakeholders who are mechanical engineers, electrical engineers, all kinds of logistics engineers, all these other disciplines, safety, security, all these other disciplines that have nothing to do with object-oriented, and to have no idea what you're doing, because most of those things are procedural. And so you have to create a process for people, and that's what they can understand and see and assimilate easily in those other disciplines. And so that's, I think, the real problem that we're seeing with it. So it is both SysML and the tools that implement SysML, because without concordance, the tools don't really add that much value. It's over using Office. I mean, obviously you're going to use Office these days. You're not going to do them by hand. I'm not using a typewriter. so that's the only comparison I could make.
Oh, to follow up, could ROI calculations be decoupled from the tools?
Maybe, but again, since we're talking model-based systems engineering, and that really is focused on the application of tools to do systems engineering, I'm not sure how you fully can decouple it. But you can certainly try. I'd be willing to see that.
So next question. I'm a former MD Doors user and cannot agree more with all the drawbacks of those tools that you mentioned. Have you considered comparing Innoslate to all-in-one tools that seem much easier to use, such as Cradle?
Yeah, in fact, we use Cradle. We actually worked on the NASA Constellation program. We're training people in using Cradle. So we're very familiar with that. That's a very good tool. But again, it isn't doing some of the things I think you need to do, like adding in the new technologies for NLP. It's not cloud-based, which again is everybody's moving to the cloud. I'm sorry, it's what's happening. So you have to re-architect for that. And so that takes a major amount of work that most people don't do. We re-architect all the time. We re-architect every 3 years or so our tool. So we're always looking at the latest technologies and trying to adapt those and see what we can do to improve the tool. So that's why we have a feedback form on our dashboard for you to give us good ideas on what you want to see and what you need to do your job, because that's what we're here for. We're here to help you do your job.
Next question, are slides available?
Yes, they'll be available. I think we can make those available to you, not a problem. So.
Absolutely.
Okay. Any other questions?
Yeah, how much training is needed for Innoslate?
So again, It really depends on how familiar you are with this kind of tool. If all they're familiar with is the office tools, then there's a kind of a change in thought process that needs to occur. So we usually get that through people, and usually within a day, and particularly if they will, but they can do it themselves. I mean, frankly, they can go in and start playing with the tool immediately. There's a free version that they can play with to their heart's content, and you can go ahead and learn it that way and pick up the YouTube videos and things like that and pick it up pretty fast. But if you really want to get into it in depth, and particularly if you haven't done functional analysis, I highly recommend a training course for that purpose, because then we can help you see how to use that and apply it to your problem. So I think that's important too.
Okay, that looks like that was the last question.
Oh, cool. Okay, great.
Well, that concludes the question and answer portion of the webinar. If we didn't get to your question, do feel free to reach out to us after the webinar. We'll be able to answer those also again after the webinar.
Sorry.
It's all good. We would like to thank you again all for joining us for today's webinar. As a reminder, we will be following up with you very soon to send you a link to the recording and the presentation slide deck. So we will encourage you to visit our website and our blog as well, and connect with us on social media. You can request to join the InnoSlate user group on LinkedIn for updates, news, and tips and tricks related to InnoSlate. That concludes today's presentation. Thank you again for your attendance, and enjoy the rest of your day.